In these presentations, we are going to talk about the vector and scalar quantities and how we can add or subtract these quantities. To review, the physical quantities can be divided in scalar quantities and vector quantities. The scalar quantities can be described just if we know the magnitude of the quantity and the unit and the respective unit. But in case of the vector quantities, in order to describe that quantity, we need the magnitude and the direction. And some examples we can mention in case of the scalar quantities can be time, can be speed, mass, length, distance, area, volume, density, and temperature. Then to describe any of these quantities, just we need a number and the unit. For example, time, 5 minutes. Area, 25.6 centimeters square. But in case of vector quantities, we can mention some example like displacement, velocity, acceleration, or force. Then, for example, if we want to apply force, then we need to know in what direction we need to apply the force. Yes, we need to apply to the left, to the right, or in what direction we need to apply the force. Then this is why all these quantities are vector quantities. Now, how we can add or subtract these quantities? Let's start with the scalar quantities. Then scalar quantities that have the same units, we can add or subtract them according to the rules of algebra. For example, if we had 50 minutes minus 10 minutes, then the answer is 40 minutes. Then just we add or subtract them using the algebra rules. Then if we had 5 kilograms plus 2 kilograms, then we had 7 kilograms. But in case of vectors, we cannot do that. Then because as we know, vectors are completely described if we know the magnitude and the direction. Then when we add or subtract vector quantities, we need to take into account the direction. And this is why to add or subtract vectors, we need to one of the ways we can do is using the graphical method, and this is the way we are going to learn in this course. Then now let's see how we can represent the magnitude and the vector graphical. Then we can use an arrow to represent a vector, where the arrow start corresponds to the origin or the tail of the vector. The tip of the arrow corresponds to the head, and this indicates the direction of the vector. The length of the arrow corresponds to the magnitude of the vector. And let's see now how we can add the vectors. And let's see what happens with the collinear vectors. Collinear vectors are vectors that have the same direction, or we can say just vectors that are parallel or anti-parallel. Then if that happens, is the only case in which we can add vectors algebraically. And let's see what happens if the vectors are parallel. If the vectors are parallel, they have the same direction. Then if we add these two vectors, we will get a new vector, and this vector is called the resultant vector. In this case, because we had two vectors that had the same direction, they are parallel and they had the same direction, then just we can add the vectors together and keep the direction. And for example, we had here two velocities, 50 miles per hour east plus 40 miles per hour east. We can add this, like we can add the numbers, 50 plus 40 is 90 miles per hour east. Then we add them together and keep the same direction. Then what happens if the vectors are anti-parallel vectors? In that case, we will subtract the smaller magnitude from the larger magnitude, and we will use the direction of the larger vector. For example, we had 50 miles per hour east, as this direction. Then we had 40 miles per hour west. Then these vectors, they are antiparallel. Yes? One is in east direction, the other is in west direction. And in this case, we will subtract the smaller from the larger quantity, will be 50 minus 40, will be 10. And then we will keep the direction of the larger vector. In this case, will be east. And the resultant vector, which is this one, corresponds to 10 miles per hour east. And now how we can add coplanar vectors. What is the coplanar vectors? Are vectors that they lie in the same plane. Yes. All these vectors, they lie in the same plane, A, B, C, and D. And what happens is, to add vectors that are neither parallel nor antiparallel, we need to apply the graphical method. And remember, we can use the algebra rules only if the vectors are parallel or antiparallel. Now, what happens if they are no parallel or antiparallel? Then we need to apply the graphical method. Now let's think we want to add these three vectors, A, B, C, and we want to find the resultant vector as we add these three vectors. But what happens in this case? The vectors are no parallel vectors. They are no antiparallel vectors. Then what we need to do? We need to use the graphical method. Then to add using this method, we need to follow some steps. Then let's review the steps. How we will add these vectors. Then the first step is we need to draw the first vector. Then this is we will do here. As we had this, we will draw this vector. This is the step number 1. Then in the step number 2, we will draw the second vector in the way the tail of this second vector starts in the head of the first one. Then this, you can see that this is the tail of this vector. This point, we will start on the head of the first vector. And tail of the second vector start on the head of the first vector. We don't change the direction, we don't change anything, just we draw the same vector we had here. And then we will repeat this procedure. And you see this is the tail or the origin of this vector C. This point, we will start on the head of the vector B. Then the tail of the third vector will be the start on the head of the second vector. And again, we don't change anything. We don't change the direction of the vector, just we draw the vector here. Now, the resultant vector, we need to now to draw the resultant vector, and the tail of the resultant vector will be the tail of the first vector, or the origin of the first vector, and the head of the resultant vector will be the head of the last vector. Then this is the resultant vector. And let's review again the procedure. And we want to add these three vectors. Yes. They are not parallel, They are not anti-parallel vectors, and we need to use the graphical method. And we want to find the resultant vector A plus B plus C. Then step number 1, we draw the first vector, this one. Yes. On the head of the first vector, we'll draw the second vector, as the vector B. Then the tail of this one will be on the head of the first vector. Draw this one, and then we will do the same with the next vector. The origin or the tail of the vector C will start on the head of the vector B, and this is the vector C. Now the resultant vector will start from the origin of the first to the head of the last one, and then we just draw the vector. Then this is the steps we need to follow. Yes. Now, but we want to know what is the magnitude and where is the result, what is the magnitude and what is the direction of the resultant vector. Then to do that, we need to use the ruler to know the magnitude of the vector, and we will use the protractor to know the direction of the vector. And let's first discuss how we can give the direction of the vectors. Then one of the ways we use to give the direction of the vectors is using the cardinal points. If the vector is parallel to any of the cardinal points, then there is no problem. Yes, if it's in north direction, then we will say that vector is point to north, east, south, or west. But what happens if the vector is not parallel to any of these cardinal points? Then if the vector is in one of the quadrants, what we say in one of the quadrants is, for example, is like that. We had 4 quadrants here, then let's say we had here in this direction. We had this vector. And this is in the northeast quadrant. Then how we will give the direction of the vector? Depending how we measure the angle. For example, if we measure the angle, if we measure this angle, and let's think this is 25 degrees, then we will give the direction like that. We will say this vector, the direction is 25, is of north. Is from where we start measure the angle will be the last cardinal point. For where we start measure the angle will be the last cardinal point. Then we can give also the direction of this vector if we measure the other angle. Let's think now we measure this one, and we know this will be 65 because here is 90 degrees, and will be 65. The other possibility, we can give the same direction. The direction of the vector will be 65 degrees. But in this case, we will say is north of east. Then from where we start measure the angle will be the last cardinal point in the direction of the vector. Then this is why here we say 25 east of north and 65 north of east correspond to the same direction. And we can give the direction of this vector either this way or this way. But we need to be careful because 25 east of north is not the same as 25 north of east. Yes, it's not they are not the same. And probably we can try see if we can let me. And we can see these two vectors that this direction doesn't correspond to this direction does not correspond to the same vector. And 25 is of north, and means we will start from north. Yes, is this vector. And this is 25, and this corresponds to 25 degrees. 25 degrees is of north, but 25 north of east correspond to some vector like that. This is 25 degrees, then this is 25 degrees, and we start measuring from east, yes, because this is the last cardinal point. North of this, let me write like that. I don't have enough space there. Then you can see these two directions doesn't correspond to the same direction. Yes, and here we had two different vectors, but in the first example we had the same vector. And here I have few more examples for this vector, and we already discussed this one is 25 east of north. And we can say the direction of the vector, let's start with B, northern B, then will be 30 degrees east of south, as how is represented here, because we start measuring from south. In this case, the direction is represented here will be 80 degrees west of south, because we start measuring from south. This one is 45 west of north, and the reason is we start measuring from north. Always the last cardinal point corresponds to where we start measuring the angle. When we are going to add vectors, the problem can give the vectors like that, as the vectors explain what is the magnitude. In this case will be 40 kilometers north. For the second vector will be 20 kilometers east. For the last will be 30 kilometers at 55 south of east. Also, they can give the representation of the vectors, as they can be like that. As they can give these three vectors, and then you need to add them. Then what we will do first, we will learn how to graph vectors, and then we will try to add these three vectors in the next slide. And first, learn how we can graph vectors. To graph vectors, if we want to add these three vectors, then the first thing we need to choose is the scale, and we need to use the same scale to graph all the vectors. And in my case, I will choose 1 centimeters equals to 10 kilometers. You can choose, for example, 1 inch equals to 10 kilometers. And you can use any scale, but just you have to be consistent. You have to use the same scale to draw all the vectors. Then for that we will use a ruler to indicate, to measure the scale. And to draw the first vector, and it's in north direction, we know it's in this direction, then we will use the ruler and we will say 1, 2, 3, 4 correspond to 40 kilometers. Then use the ruler. For the second vector, we will do the same. It's in east direction, then 20 kilometers correspond to 2 centimeters. Then 1, 2 centimeters. Yes. Then we draw the second vector. For the last vector, we had to be careful because the vector is not parallel to any of the cardinal points. And in that case, we need to use the protractor. And the first thing is south of east. And we know this vector is somewhere here. Yes, we know this vector is here because it's south of east. And we know we need to measure 55 degrees starting from east, because this is the last cardinal point. Then it's 55 here. Yes. Yes, this is the vector we want to measure. And to do that, we will use the protractor. Then here is the protractor. You see, because we want to start in measure from east, then you see the 0 must be coincide with the east cardinal point. And we will use, you have to be careful, because this is the 0, we will use the external scale. And we will measure 55. Then you will do some mark here to indicate this is the direction you want. Yes, this is the 55 where you want to draw the vector. And you count, this is 55. After that, you know in what direction, then you will use the ruler to measure the 1, 2, 3. 30 kilometers correspond to 3 centimeters. In what direction? In this direction we want to measure. Yes. And now we know how we can draw vectors using a ruler and the protractor. Now, let's think this is the problem. This is what we want. We want to add these 3 vectors. And let's follow the steps to add these 3 vectors. And step number 1, we draw the first vector, 40 kilometers. We already know this is the scale we are going to use. Then we draw the first vector. Use the ruler to draw the vector. Then 1, 2, 3, 4. Yes. Use the ruler, use your scale, and draw the first vector. The second vector, to add vectors, the second vector, we need to draw the vector in the way the tail of the vector B start on the head of the vector A. Yes, then here we want to draw the vector. Yes, we want to start the vector B on the tip, yes, on the head of the first vector. Then will be 20. Then here is the second vector. Now we need to draw the third vector, and we need to do this exactly the same. On the head of the second vector, we want to start the vector C. But here is 55 south of east, and we know the first thing, if the vector is not parallel to any of the cardinal points, then we need to use a protractor first to measure the direction, and then we will measure the magnitude of this vector. Then remember we did before. This means we need to measure 55 degrees, but we need to start from east. And here is the east, 55, and we just mark here. This is the direction. In this direction I want to draw the vector. And now I know the direction. Now I will use the ruler to draw the vector with this magnitude. Then 30 kilometers means 3 centimeters. In what direction? In this direction. Yes, in the direction I mark here. Then we draw the 3 vectors. Now we want to find the resultant vectors. When we say the resultant vector, we want to find both the magnitude and the direction. Then the first thing is we will draw the vector. We start from the origin of the first vector to the head of the last one. And it's important to draw the tip of the arrow, because this is indicated in what is the direction of the vector. Then this is the vector A. Yes, this is the vector 8. This is the vector B. This is the vector C. And this is the resultant vector. Yes, the resultant vector. To measure the magnitude of the resultant vector, we will use the ruler. Then we use the ruler 1, 2, 3, 4, 4.2, about 4.2. Then 4.2 centimeters indicate the magnitude of the vector is 42 kilometers. Then this is my scale, but I need to use that scale to give the real to give the magnitude of the vector using the correct units, yes, which is kilometers. Then to measure the magnitude, we use a ruler, yes. Now to measure the direction, we need to use the protractor. Then this is the vector we want to measure. And this vector is in this quadrant, as is like this one is here. And there is two possibilities. You can measure this, or you can measure this angle. Let's measure this one. Let's measure this angle. And if we measure this angle, you see this is east. We start from east, then will be about 24 degrees. Yes, this is about 24. Always from what axis for one axis you want to start measure, then you had to coincide the zero of the protractor with that axis. In this case, we want to start measure from east, then this is why the zero of the protractor coincides with the east axis. Yes. Then now we had 24. Then now we can say the direction of this vector is 24 because we start measure from east, then this is why it's north of east. And maybe I will just write here. And this is 24. And this is east. Here is north. North. Then it's 24 north of east. Now we can now say the resultant vector, this vector, yes, is 42 kilometers at 24 north of east. The other possibility can be also, this is another possible answer. Yes, it's 42 at 66 east of north. Yes, if we measure this angle, then can be another answer. But this is okay. I think this will be easier. Yes, but the other is also this answer is also right. This is another way we can also measure the same direction. If we measure this angle, means if we start measuring from north. Okay, this is all I had to discuss for today.